All right, so we have gotten through actually 5 lessons in Chapter 2. This 2.2a makes it the 5th, even though it's not labeled Lesson 5. So before we get into the mid-chapter checkpoint, which is the next thing in our book, I want to do some review with you, just so we can remember what we have done, and since we just took a couple of days off from school. So we start with Lesson 2.2a, which was the adding and subtracting, and then we'll get into the Lesson 3 and Lesson 4, which was the multiplying and cross-reducing. So when we get into adding and subtracting, we have to remember there's questions to ask. And the question is always going to start the same no matter what function of math we're going to do. Remember, we have adding and subtracting, multiplying and dividing. So we have those 4 different functions that we can do. And we have to make sure we ask those questions, because when we get in division, that's a just, no, I can't do it. So let's look at our questions. Can I add fractions or can I subtract fractions? And we said that answer is always going to be yes. But there's a stipulation there. We always ask them, well, what do I have to have? And that's the common denominator. So the easy ones are if I have the common denominator that I know, I'm just going to keep that denominator, and then I do the math with the numerators. So I keep my denominator if it's the same, and if it's adding, I add my numerators. If it's subtracting, I subtract my numerators. The trick comes where if I don't have a common denominator. If I don't have a common denominator, then I'm going to have to find a common denominator. So the book showed you 5 different ways. You can find the least common denominator. You can find a common denominator if there's the smallest one, will go into the largest one evenly. Or, as I said, the way that will always work no matter what is to multiply by opposite denominators. Does that mean you might have to reduce at the end? Yeah, most likely. But I would rather reduce knowing that the steps that I'm doing is always going to work. So let's see what we're talking about. So I've given you 3 practice problems. Make sure you're following along. There's only going to be 3 here, and I believe 3 on the next one, and then we're going to do your assignment. So it should be rather quick, but when I look at it, I know that I can do it. I know it's adding, but I don't have that common denominator, right? So there's 2 ways to do this one, and I'm going to work both ways for you. I've given you enough room in order to show both ways, and I think it's good that you know both ways that it can be done. The first way I'm going to show you is the way that will always work. If I have a 3 and a 12, then I'm just going to multiply by my opposite denominators. If I see that I have a denominator of 12 on the right, I'm going to multiply numerator and denominator by 12 on the left. Remember, that doesn't change the value of my fraction, it just changes the digits that make up the numerator and denominator. Then if I have a 3 on the left as my denominator, I'm going to multiply numerator and denominator by the 3. So that renames both of my fractions I'm working with. So coming down here then, I see that when I have 12 times 3, I get 36. When I have 12 times 2, I get 24. Doing my right side then, 3 times 12 is 36, and that's what I'm needing. And 3 times 1 is 3. Now I can go back to this question. Do I have the common denominator? I do. So what am I going to do with it? Well, I'm going to keep it, and then I'm going to add my numerators. So when I keep it, then I have 24 plus 3, that's my 27. Always check to see if I can reduce my fractions before I say that's my answer. I can reduce that. Now, I could reduce it 2 different times. I could reduce it by 3, and then I'd have to reduce it by 3 again. But if I see that the largest number that will go into both of them is 9, then I can just do a 1-step reducing. Once again, more than one way to do a math problem, and if you want to do multiple steps of reducing, as long as you get to the final answer, I'm good with it. If I do it in 1 step, then 9 goes into 27 3 times, and 9 goes into 36 4 times. That's my final answer. Remember, there's 2 ways. So the second way, when I'm looking at it then, I can see that my 3 will indeed, my smallest denominator, will go into my largest denominator evenly. Sometimes this will work, sometimes it won't. If it will work, then I just have to change that first fraction. So if I have 3 will go into 12, well, how many times? Well, I have to do 3 times 4. That's going to change my fraction. So when I multiply numerator and denominator by 4, so that I have a denominator of 12, which is finding that common denominator, that gives me a new fraction of 8/12. Because 4 times 3 is 12 and 4 times 2 is 8. Now I have 8/12 plus the 1/12 that I started with. Now I have my common denominator, and so I'm going to be able to keep it, and then I add my numerators. 8 plus 1 is 9, 9/12. But once again, always check to see if you can reduce, which I can indeed. 3 will go into both of those, and when I reduce those, what do I get? Well, 3 goes into 9 3 times, 3 goes into 12 4 times, I get the exact same answer. More than one way to do a math problem. Either way is correct as long as you get to the right right answer, and it's a logical process in order to do it. All right, so when I come down to number 2 and I start looking at it, then same questions. Yes, I can subtract. I need a common denominator. Do I have it? Yes, indeed. So all I have to do is keep the denominator, which is 18, and then I can do the math with my numerators. And 11 minus 3, it gives me 8. So now I have to reduce. They're both even, and 2 is the only one that will go into it, so I'll reduce by 2's. 2 goes into 18, 2 goes into 8, then I end up with 4/9. 4/9 is as low as I can go, so I know that 4/9 is my final answer. On number 3 then, once again, as I said before, there are 2 ways that I can do that one, just like above. So I'm going to do it both ways just to make sure you know what the 2 ways are. So when we do it 2 ways, I'm going to start with the one that will always work no matter what I'm doing when it comes to adding and subtracting the fractions. I look at both of them, I see a 15, I see a 5, it's not a common denominator, so I just multiply by my opposite denominators. I see a 5, so I'm going to multiply denominator and numerator by 5. I see a 15, so I'm going to multiply numerator and denominator by 15. Once again, not changing the values, just changing the digits in the numerator and denominator so that I'm renaming it. Once I've done that then I write the new fractions I have created. I've created, well, 5 times 15 is 75, and 5 times 4 is 20. And then I also have 5 times 15 is 75, and 2 times 15 is 30. Now, do I have a common denominator? I do, so I keep it. So I keep that 75, and I just do my math with my numerators. And 20 plus 30 makes 50. Need to reduce, right? Well, I'm the type of person I like to think about quarters because that is an easier process for me when it comes to these type of numbers. And I know 2 quarters make 50 cents, and 3 quarters make 75 cents. So that has to be able to reduce by 25s, which is going to give me an answer of 2/3. So the second way then, well, if I go back to what I originally had and I looked at it, I could see that the 5 will indeed go into the 15 evenly. So then I asked, well, how many times does it go in? Well, 5 goes into 15 3 times. So if I multiply that 5 by 3, I know I'm going to get a common denominator. And if I multiply the bottom by 3, then I have to multiply the top by 3. That's going to rename my fraction. I'm going to end up with 5 times 3 is 15, 2 times 3 is 6. Now I have my original 4/15 plus my new one, my 6/15. I have a common denominator, so I'm going to keep it, and then I add my numerators. 4 plus 6 is 10. Still I have to reduce. So I'm going to reduce by 5s, and look what I get. 5 goes into 10 2 times, 5 goes into 15 3 times, so I do indeed get the exact same answer. More than one way to do a math problem, as long as it's a logical process and you can always repeat it and be successful with it, I'm good with you doing it that way. Then we had lesson 3 and lesson 4, so I'm going to mix those together because multiplying and cross-reducing, really cross-reducing is a quick way to make your math a little bit easier because I don't have to use such big numbers. I'm going to make it into smaller numbers, and I've said all along, I enjoy working with smaller numbers because it eliminates a lot of the chances that I have of making mistakes. So if I make smaller numbers first, then that means I'm going to cross-reduce anything that I can. So remember, when cross-reducing, then I have a numerator and denominator that I can cross-reduce, or a numerator and denominator that I can cross-reduce. And every once in a while, they try to trick you. I could have a numerator and denominator that are actually stacked together in the math problem that I can reduce. I'm never going to reduce this way. Has to be diagonals or straight up and down where it's a numerator and denominator. Once I cross reduce, then I go through the same process. Can I multiply? Yes, I can. Now what do? I just do the math, right? So I'm going to multiply straight across. That's how I multiply fractions. Then when I get to the end, then I'm going to reduce or simplify if I can. If it's a top heavy, if it's an improper fraction, I simply convert it into a mixed number. Now this is where we introduce that new thing, right? Where we're going to change a mixed number into a improper fraction and improper fraction. So I'm going to start at the bottom. I'm going to multiply. So I'm going to have my denominator multiplied by my whole number. Whatever that answer is, then I add, and then I carry that over, and that's going to be my numerator. I always keep my denominator then. Here's an example. So 2 1/2. I'm going to start at the bottom, and I'm going to multiply. So I take my denominator of 2, multiply by my whole number of 2, and I get 4. My second step, then I add. So I'm going to take my answer that I got, I'm going to add it to my numerator, and that becomes my new numerator. The 4 plus 1 gives me 5. Then, my last step, I keep my denominator. My original denominator was 2, so I keep it. The one I didn't include on here was whole numbers. Have to always just simply put whole numbers over 1. So these 2 steps are at the very bottom of that original sheet that I gave you that shows us all the steps and questions of adding, subtracting, multiplying. On the back side is division, which we get into after our mid-chapter checkpoint. So I have 3 and only 3 practice problems here. Please make sure you're following along as we're going through this. So in the book, and these are just from the book, I did change them a little bit over there, but they already showed you that I can cross-reduce. So I have my multiplication. Am I allowed to multiply fractions? Yes, I have to multiply across. But if I want to make a problem easier, I cross-reduce where I can. Here I have 5 and 10. Those can cross-reduce because 5 is a factor of 10. And I have 3 and 6, and those will cross-reduce because 3 is a factor of 6. So when I do my 5 and 10, that means I'm going to reduce them both by 5. Once again, the word reducing means to divide by the same number in the top and the bottom of a fraction. 5 goes into 5 one time, and 5 goes into 10 2 times. Then I add the 3 and the 6. 3 will go into both of them, so that's what I reduce by. And 3 goes into 3 one time, and 3 goes into 6 2 times. Now I just multiply across. So I draw my arrows so I know which ones I'm matching up. I have 1 times 1, which gives me my numerator, and 2 times 2, which gives me my denominator, and I just simply end up with 1/4. On number 2, what I just mentioned to you, a whole number, so that does have to change. I have to put that over 1. Don't ever change it. Okay? 3 cookies compared to 1/3 of a cookie is not going to be the same value. So I always put my 3 over 1 because any number over 1 is that value of the numerator. When I have it set up, I see if I can cross-reduce. Remember, cross-reducing doesn't have to be done both directions. I could choose to only cross-reduce one of them. And at 3 and the 9, that can be cross-reduced. So I know that 3 will go into both of them, so I reduce numerator and denominator by 3. 3 goes into 3 one time, and 3 goes into 9 3 times. Now, I look at what I'm left with. There's nothing can be cross-reduced. I multiply across. I have my 1 times my 5, which is 5, and 1 times my 3, which is 3. But that's top-heavy, right? That's that improper fraction, which I can't have in my final answer. So I know I have to do what mathematically to get my final answer. Hopefully you thought fractions are division. So I'm going to take my top number. It goes inside my division box. My bottom number is always my divisor on the outside, and then I divide. Now this is not one where I'm going to change it into a decimal and get repeating numbers or anything like that. Whatever the remainder is, I change it into the fraction. So I know that 3 goes into 5 one time. That's going to be my whole number of my answer. But what's left is 2. So remember, my remainder is my numerator. My divisor is my denominator. So that tells me how to set up my fraction. I have my whole number of 1. My remainder is my numerator. My divisor is my denominator. Now we get into 3, where we had to create the improper fractions. So I'm going to change both of those. So I'm going to drop down here in this extra space down here to do that. I start at the bottom. I go 3 times 2. Well, 3 times 2 is what? 6. And then I have to add my numerator. 6 plus 2, that's my new numerator. So I know my new numerator is 8. I keep my denominator of 3. I do the same thing with 2 9/10. So on 2 9/10, I start at the bottom and I multiply with my whole number. So 10 times 2 is 20. Then I add that to my numerator. 20 times 9 is 29. So that's my new numerator. I keep my original denominator of 10. These two fractions is what I plug in to create my new multiplication problem. Is there anything in cross reduce? Well, there is one set. I have my evens of 8 and 10. 2 will go into both of them, so I cross reduce those. 2 goes into 8 4 times, and 2 goes into 10 5 times. And anything else? Well, does 3 go into 29 evenly? If I add 9 and 2, 9, 10, 11, it doesn't, does it? Because 3 doesn't go into 11 evenly. So I'm going to multiply across to get my answers. 4 times 29 is 116, and 3 times 5 is 15. That's top heavy. I know I have to divide to get my mixed number as my answer. So my top number of 116, my numerator, has to go inside my box. My denominator of 15 has to go on the outside of my box. Then I just divide and find out what my whole number is. I type it in my handy dandy calculator, 116 divided by 15 equals, and I see that I have a whole number of 7 and stuff, and I get rid of that stuff. I have to find out then what my remainder is, and I just do 7 times 15 is 105. When I subtract those, I get 11. So once again, my whole number is part of my answer, but then I remember that my remainder is my numerator, my divisor is my denominator, 7 and 11/15 is my final answer. That's all there is to the review. It was only 6 questions. Hopefully you followed along and took all of your notes, and if you didn't, I advise you to rewind. It's a short video today, and I'm giving you plenty of time to get all, I think it's 16 or 17 questions done here in class, so you don't have to worry about homework tonight. So make sure that you go back and rewatch it if you didn't take all of your notes. If you have questions and while you're working at it, just come back and ask.